Now, this drag force problem is pretty frequent in AP test environment. So it's really not a bad idea to take a look at this so you don't freak out when you see something like this on a test. Once you go through it once or twice, it's just going to make you feel so much more confident, I think. Okay? So let's take a look at what happens at drag force problem. Consider a skydiving cat that forgot the parachute. It's okay because cats usually land on their feet, right? In a free fall motion. Let the air resistance force be directly proportional to the cat's velocity such that the magnitude of the force given by F drag is equal to B times V. So that's the drag force. And it will depend on how fast the cat is moving. The drag force increases directly proportional to the speed of the cat. Assume the cat started falling with zero initial velocity. A, draw a free body diagram for the cat in a free fall. Okay, well, let's pretend the cat's center of mass is right here. Okay, and draw a free body diagram where we have obvious force for the cat will be Fg, right? The weight of the cat, which is equal to mg, right? And the other force will be the drag force. Now the drag force will start from zero and it will steadily increase depending on how much the cat has fallen and how much cat has increased its speed. So the F drag, right, is equal to B times V. So right there is part A. Now I'm going to consider the direction of motion to be positive. So the downward direction for the cat, I'm going to consider that positive, and the upward direction, which is resistive force, negative. Okay? So that was part A. Part B. Use Newton's second law to derive the equation, right? The differential equation that governs the cat's motion. So we start out with Newton's second law. The sum of all force, the net force, right, is equal to ma. Well, we also know the sum of all forces are just adding up all the forces that are involved. And that looks like I have two forces. One is the Fg, which is the weight, and the other one is the drag force, F drag. So we can now set these two equal to each other and say ma is equal to Fg is positive and F drag is negative. So if we were to replace the A with a differential equation, my acceleration is nothing more than just dv over dt. And that is equal to, right, mg minus dv. And that's all they want to know. Okay? That's all they want to know. All right. Part C. Derive an expression for the cat's maximum velocity. This velocity is called the terminal velocity. So I think it's important to know this maximum velocity and the terminal velocity are the same thing. Now, terminal velocity happens, right, when acceleration of the cat is equal to 0. Okay? So terminal velocity or the maximum velocity happens when the acceleration goes to 0. So in the beginning, right, in the beginning, I guess the FG is much bigger than, I guess, BV, okay? Because the cat started out with 0 or almost negligible velocity, so it's, the drag force is negligible. So the weight force is much bigger than the drag force. In the middle, right, your cat's weight is still bigger than BV, right? Because now the V is picking up and this BV value is going to get bigger. So your MG is constant, it's going to stay the same. So since this is catching up and this is going to be bigger, but not as in the beginning. Now the terminal velocity happens, right? When the acceleration goes to 0, okay? If that's the case, then this goes to 0. When this goes to 0, this whole term goes to 0, right? So if we were to rewrite this, right? If we were to rewrite m dv over dt is equal to, right, mg minus bv, at terminal velocity, this goes to 0. That means 0 is equal to, right, mg minus bv. Okay? Therefore, my v, if I solve for v by bringing this to the other side, so my bv is equal to mg. So my v, which is v max now, right, which is equal to v terminal, right, is equal to mg over b. This is terminal velocity. It's a very Asian thing. Yeah. All right? That's when the terminal velocity happens, when mg over b happens. All right. So now let's take a look at part D. For part D, by separation of variables, solve the differential equation of motion to get an equation for velocity of the cat, v of t. So we want to find the function of the velocity of cat. Identify the time constant for this motion and explain its meaning. All right, well, let's take a look. We'll start out with, first of all, we'll start out with this equation right here. Okay, we'll start out with this equation. So here, I'm going to start out with mg minus bv, right, is equal to m times dv over dt. I'm going to start with this equation, the differential equation that we derived for part B. I'm going to separate the dv and dt to the other sides. So I'm going to bring this dt to the other side. And since this variable v is here and we have dv here, I'm going to have to bring that down here. So dt is equal to then m over, I'm going to go with one color now. Okay, so here, mg minus bv times dv. Okay, now I need to integrate both sides. So if I integrate this side, I get from 0 to t dt. That's easy integral. However, when I integrate this side, I get m over mg minus bv times dv. Looks like I'm going to have to do like integral by U substitution. So I'm going to consider this whole thing to be U right here. Right? This is U. So my U is equal to, right, mg minus bv. Du is equal to, well, this goes to 0, this constant, minus b dv. Right? So I'm going to need a factor of 1 over negative b out in front. Right? So I'm going to need negative 1 over b out in front to have my negative b here. So this whole thing is u, right? And then m over u du, right? So if I factor out this m, I'm going to get negative m over b, right? Integral of, right? I get 1 over, well, du over u, basically, right? Are we okay with that so far? Right? Integral by substitution, u, right? So this basically becomes t from evaluated from 0 to t, right? Now, I'm going to bring this to the other side, and then I'm going to get t minus 0, right, times negative b over m, right, is equal to, right, ln u, which is equal to ln, right, mg minus bv evaluated from 0 to v. Okay, so for this side is just going to be t, you know what, forgive me, but I just want to say m over b here. You'll see why later. I'm just going to divide this t by m over b, okay, is equal to, here will be ln, evaluate with v into my v, and I get mg minus bv, minus, plug in 0 for my v, and I get ln times just mg, because if I plug in 0 for my v, this whole term goes to 0, and that's what I have. And by natural log property, right, this can be written as ln of mg minus bv over mg. Okay. Now I will take e to the both sides. Right? Take e to the both sides. If I do that, on this side I get e to the negative t over m over b is equal to e to the ln goes away, and I get simply mg minus bv whole thing over mg. Now it just becomes algebra. I'm going to multiply both sides by mg, so I got mg, right, e to the negative t over m over b is equal to mg minus bv. I'm going to bring this negative bv to one side, bring this to the other side, okay? So I'm going to have bv is equal to mg minus mg times e to the negative t over m over b. I'm going to factor out the mg, divide both sides, well, 1 minus e to the negative t over m over b, and divide both sides by b, and I get my v. So this is what the velocity function should look like. So my v of t, right, velocity as a function of time, is equal to mg over b times 1 minus e to the negative t over m over b, right, is my function of velocity with respect to time. This should look familiar. mg over b, what is that? That's my terminal velocity. So this is my terminal velocity. Right? So what happens as t approaches infinity? So if you take a look at here, right, as t approaches infinity or large number, this goes to e to the negative t over m over b goes to what? Goes to? This is the same thing as 1 over e to the positive t over m over b. So if this goes to be infinity, e to the infinity becomes a large number. So 1 over large number goes to 0. Does that make sense? Right? Then that means for this whole thing here, as t approaches infinity, right, as t approaches infinity, this whole term, right, 1 minus e to the negative t over m over b goes to 1. That means as t goes to infinity, my v of infinity goes to mg over b, which is v terminal. which is my Vmax. Does that jive with you guys? Okay? Okay? So we should learn how to analyze that. Okay, we should learn how to analyze that. All right. Next, part E. Well, let's graph this. You're like, no, are you kidding me, Mr. Kim? Yeah, I'm not kidding. It's not that hard. It's not that hard. So when we graph this thing, we know this mg over b is equal to terminal velocity. So terminal velocity times the factor of 1 minus e to the negative t over tau. Now, they use tau as m over b. Instead of writing m over b, they just use it as tau. This right here is also known as time constant. Okay. Why? Because this pretty much tau has to be in seconds, because this m over b then has to also be in seconds, right? Therefore, this b, this coefficient b must have unit of kilograms per second, okay? So that kilograms will cancel out and you have second at the top, so the tau will be in seconds, okay? So when we graph this, this right here is my mg over b, which happens to be my Vmax, which happens to be my V terminal velocity, okay? And it starts at 0 and is going to approach that terminal velocity. Well, that was pretty cool. I did that in one shot, actually. All right. So it will approach there, but you'll never get there. That's what they're saying. But at a certain point, you know, it's so close that it's virtually or essentially becomes the terminal velocity. Okay. So let's take a look at example what happens when your tau has some kind of a numerical value. Let's think about like when tau itself is equal to like 2 seconds. Right? So let's take a look at an example. Right? Let's say tau, which is equal to m over b, is equal to, let's say, just 2 seconds. Right? So if we know the mass of the cat, right? Let's say mass of the cat happens to be like 20, like, I don't know, or whatever, kilograms, and then that's a large cat, right? Maybe like 10 kilograms. And then B is like, let's say, 10 over 2, which is like 5. Then our tau becomes like 2 seconds, right? So this factor is pretty much constant. This is time constant. So this 2 seconds will never change, okay? Now let's take a look at what happens, right, when t is equal to 2 seconds. What happens when t reaches 2 seconds with time constant also equaling 2 seconds, okay? Well, if we work it out where 1 minus e to the negative 2 over 2 right? And if you work this out in your calculator, I think you'll get something like 0.63 as your value. That means at 2 seconds, when t is equal to 2 seconds, right, tau is also equal to 2 seconds, okay? So t over tau is equal to basically 2.0 over 2.0, which is 1. And that is, right, the time constant at this point, at t is equal to 2 seconds. So what happens at 2 seconds? My velocity will be here, which is approximately 63% of my terminal velocity. Right? So 0.63 Vmax. Okay? Or we could just say 0.63 mg over b. Okay? If you take another example, let's say, what about when tau is equal to, or I should say, time, t is equal to 4 times tau, right? That means t is equal to 8 seconds, basically, okay? Because if we say t is equal to, like, I don't know, 2 seconds here, then it should be 8 seconds. Well, basically, then this 1 minus e to the, right, 4 tau over tau negative, right, just becomes 1 minus e to the negative fourth. Right? That, if you evaluate this, comes out to 0.98. That means at 4 times tau seconds, or in our case here, it would be like 8 seconds, right? My V is equal to 98% of Vmax. Dyslexic. Vmax. Okay? So at 98% of the Vmax is essentially a terminal velocity. Okay? Okay? So if you go 10 seconds, let's say, right, then it'd be like 5 tau, and then you're going to even get even closer to 1, right? Etc. Okay? So, I don't know, 4, 6, 8, like, I don't know, like right here, it's going to be like somewhere around here. So I'm not going to even do it, but this will be like, t is equal to 4 tau. This is like 1 tau. T is equal to like 1 tau. Here's 4 tau. And this will be like 98%. Right? notice it is still under that dotted line. All right, you get the point, right? All right, last part will be derive an expression for the acceleration as a function of time, a of t. Well, okay, well, in our case, my acceleration is equal to dv over dt, right? That means I've got to take pretty much the derivative of this function right here. And since my v of t happens to be, right, v terminal times 1 minus, right, e to the negative t over tau, right? If I take a derivative of this, right, basically, I'm taking derivative of, I'm going to distribute this through. Right? That looks like e to the u. Right? So if you take a derivative of e to the u, you get e to the u du. All right? So this looks like, I could say this as u. Right? So if u is equal to negative t over tau, and du is equal to negative 1 over tau. Okay? So my dv over dt is equal to, when I take a derivative of this, it's going to be just 0, right? Because this is constant, minus v terminal e to the u, which is negative t over tau, times du, which is negative 1 over tau. Right? But what is v terminal? V terminal, we said right here, is mg over b, right? So here, this is mg over b, negative, times e to the negative t over tau, times negative tau, again, is m over b, so 1 over m over b. Well, it looks like things are going to cancel out nicely, right? Because here, my dv over dt then is equal to, it looks like these two are going to cancel out to be positive. Right? So these two are going to cancel out to be positive. If I flip this, this will be b over m. So m's will cancel out and b's will cancel out. Right? So this will just give me g times e to the negative t over tau, which is m over b. So that would be my acceleration. So my acceleration as a function of time will be g times e to the negative t over m over b as my acceleration function. So this looks like an exponential decay, right? Right? So if I were to graph this, now you don't have to obviously do that to answer the question part F, but let's visually analyze this, what this may look like. So here is my A of t, and here's my time t, right? It looks like it's going to start at when t is equal to 0, when this is equal to 0, right? It looks like this whole thing is going to turn into 1, and 1 times g is just g. So when t is equal to 0, my acceleration is g. Then it will decay to 0 as it approaches infinity. Okay. Like so. Wow. So when you see something like this, don't freak out. Okay? Because now you've seen it, it should not freak you out. All right. Now, I'm going to stop this, and then I'm going to see if you can actually show me that you understood what we just did. Now, this is straight out from AP test question, from previous AP test question. This basically is a drag force problem where as car approaches a higher and higher speed, the drag force will be kV, right? So this would be very similar to what we did. The constant force of F naught is applying this way, right? And the drag force will actually increase as my speed V increases the other way. So think about what we just did, like, we just did it basically like this, where F naught is mg, right? And then it was BV this way, but instead of BV, it would be KV, and F naught will be this, right? However, now it's on the flat ground, so when you draw a free body diagram, don't forget the y-axis. Okay. So I'm going to see if you can do this, give it a shot, and then we'll go over this towards the end of the class, and then I'll show you how they actually give the points, the rubric of the point system for this problem as we go over this. All right? All right. So, all right, looks like a lot of people have completed this, which is good. So let's take a look at how it's been broken down for the rubrics of the point system here, okay? This is very similar to what we've been doing with the cat, skydiving cat. However, for this one, it's really just going in the horizontal direction, right? Now, don't forget though, you still have vertical forces. So here you have your drag force, kV. Now you don't have to put the negative in there because it's already pointing in the negative direction, okay? Also, you also have F naught, which is the constant force being applied by the car, right? So here's your F naught. And of course, you're going to have two forces vertically. One's going to be Fg, and the other one's going to be F normal, right? So you don't have to draw this kV same length as FO unless it is already in terminal velocity. Only when it's terminal velocity, the length of FO and kV should be the equal thing, all right? So since it doesn't tell you that it is at, so if you were to think about the point system on this one, if you drew your F naught, that is worth 1 point, okay? If you drew in your kV, which is your drag force, that's also worth 1 point. And if you drew in your mg and F normal, that's also worth 1 point. So if you, forgot the vertical forces, you're not going to get completely, destroyed with points taken away, right? All right. Now let's think about determine the horizontal acceleration of the car in terms of k, v, f naught, and m. So we start out with sum of all forces equal to ma again, right? And then sum of all forces equal to basically F naught minus KV, right? And then just by having this, just this is worth 1 point, right? F equals MA. Then when you set these two equal to each other, MA is equal to F naught minus KV, right? So if you solve for acceleration, right, just by setting these two equal to each other is also worth 1 point. Then when you solve for A, your A is equal to F naught minus KV, right, over M. And that's worth another point. Okay? Now, I know they didn't ask you for this. However, let's just say MA is equal to F naught minus KV, and acceleration when it's equal to 0 at, right, terminal velocity, right? Right? Then F naught minus KV is equal to 0. So KV is equal to F naught, and V is equal to F naught over K, and this is your V max, right? This is your V max, which is also equal to V terminal velocity, right? So even though they didn't ask you this, it might be a good idea to know that. Okay. All right, next. Now comes the evil part, right? Derive the equation expressing the velocity function. So here we know F naught minus kV is equal to m times dv over dt, right? We know that. So from here, I'm going to separate the variables by bringing the dt to one side and all the v's and dv's onto the other side. So here, my dt is equal to, right, m times, well, m over F naught minus kV times dv, right? So if we integrate both sides, we're going to get from 0 to t dt is equal to, right, again, m over F naught minus kV times dv, where u is equal to F naught minus kV, and du is equal to negative k dv, right? So in order to make this legit, you say negative k here, right? And then integrate that, and then you do 1 over negative k here from 0 to v as your thing. Just for having this equation, you get 1 point. Okay? And then setting this up right here for knowing your substitution u is also worth 1 point. So when you integrate this, you know you're going to get t out of this, right? T minus 0 is equal to, right? Here, you're going to get m over negative k, right? ln of, right? F naught, right? Minus kv evaluated from v to 0 to v, I mean. So if I bring this to the other side, I get negative t over, right, m over k is equal to ln of f naught minus kv minus ln of f naught. Then we're going to take properties of natural log, right? So here we're going to get f naught minus kv, not f, kv over f naught negative t over m over k. Now we'll take e to the both sides, okay? So here we have e to the negative t over m over k is equal to e to the natural log goes away, which will give you f naught minus kv over f naught. Multiply both sides, right? So you get f naught e to the negative t over m over k is equal to f naught minus kv. Bring this to the one side, so you got kv here, f naught minus f naught e to the negative t over m over k. Factor out the f naught divided by k, you get 1 minus e to the negative t over m over k as follows, right? So this, your v of t, is equal to f naught over k times 1 minus e to the negative t over m over k. Boom. This whole thing here, I guess from here, is worth 2 points. Okay? This here is worth 1 point. And as you know, this right here is the V max or V terminal, right? And of course, this is going to approach to 1 as t, right, approaches this, 1 minus e to the negative t over m over k will approach to 1. Okay? All right. Now, if we were to take a look at, on the axis below, sketch a graph of a car's velocity v as a function of time. Well, this is kind of obvious now because you know it's going to have to reach terminal velocity And this terminal velocity here is equal to F naught over K, right? And this is your Vmax, right? And it would start from 0, and it'll probably go doing that. So for this one, you'll get 1 point for the graph shape. Just for the shape of the graph being correct, they'll probably give you 1 point. And the other point will be recognizing your Vmax, right, is equal to F naught over K, will be the other point. Okay? Then, on the axis below, sketch the graph of car's acceleration. So, we know acceleration is equal to dv over dt. So we have to take a derivative of that acceleration velocity function. So we have to take that ddt of, right, f naught over k times 1 minus e to the negative t over m over k, right? So if I distribute this through, right, so here, the derivative of, right, f naught over k minus f naught over k e to the negative t over m over k, you could set your u, right? So e to the u as e to the u du, right? Right? So your u is equal to, right, negative t over m over k. Your du is equal to negative, right, k over m. I flipped it because it's 1 over m over k, right? So when you take a derivative of this is a constant, so it goes to 0, minus. All right, you guys at the virtual world, did you hear that? Yes? No? All right. All right. Well, you could get a Pfizer shots. So listen for the all call. All right, I lost train of thought now. You have to take a derivative of this, and it is e to the u du. So negative t over m over k times du, which is negative k over m, right? So notice how these negatives will cancel out nicely, and the k will cancel out here. So your acceleration, which is dv over dt, right, is equal to f naught over m times e to the negative t over m over k as your acceleration. All right? So that is your acceleration function for your car. So if you were to graph this, your acceleration maximum will be f naught over m, right? So here's your acceleration, f naught over m as your a max, right? And it will pretty much decay from there to 0 as we approach infinity and beyond. All right, so having the correct graph shape will be worth 1 point. And recognizing that A max is equal to F naught over M will give you the other point. All right, thanks for your patience, and hopefully this helps. All right, listen out for the all call for your vaccination opportunity at Conestoga. All right? All right, have a nice day, everybody. See you Wednesday virtually. Bye.
Thank you.
Okay.
Mr. Kim, so I know we have that, the free response from chapter 13, the homework due on Wednesday. Do we submit only the free response or also the multiple choice and the free response?
Just give me the free response. Yeah.
Free response.
Yeah. Multiple choice. I'm hoping you'll be doing that, right? I'll give you the answer key, didn't I? Yeah. Yeah. Just give me the free response. Yeah, you guys can bounce because I know I'm going to have a freshman coming in here. So I'll see you guys Wednesday, okay? And if you see freshmen out there like acting very clueless, you can send them in. All right, take care. Yeah,
Would you write me a recommendation letter?
sure. When do you need it by?
You can write it. You can get it to me for by next school year. Like when I start applying, you can like write it over the summer.
Yeah, so I guess remind me.
I'll send you an email.
Yeah, through Naviance.
Okay.
You know, make sure you have everything there. And then if you can, I would like to have your resume and your transcript. And on your resume should have your SATs and all that stuff, right? And your activities outside of school is very important, and all the activities you have done in school too. And if you can also give me your like choices of your college, which ones your top choices, like top three, that'd be also very helpful.
All right, cool.
All right?
Thank you.
Sure.